Statistical control charts. This is what statistical control charts look like. They include a center line that represents the average value of the set of scores corresponding to the in-control state, and two or more horizontal lines that you see here are called the upper control limit and the lower control limit, which show the abnormalities in the collected sample. Here all of the sample points are connected with a straight line segment, which makes it easy to see the sequence of the points, which in other cases would allow us to see how those points have evolved over time. When the process is in control, almost all of these points will lie between the control limits, requiring no action to be taken. Whereas when a point in the plot lies outside of these control limits, meaning below the lower control limit and above the upper control limit, it shows that it gives us the evidence to be out of control, requiring action to be taken in order to solve this abnormality. Another case of abnormality can be when all the points lie within the control limits, meaning that they do not exceed, but they are in a systematic behavior, meaning that they are not random, meaning they could grow exponentially, indicating that the process is out of control. So in order for the process to be in control, all of the plotted points must lie within the control limit and have to be random between the two limits. Variation in statistical control charts can be studied by sampling the process, which would allow us to understand the variations, enabling us to find its causes to allow us to make better decisions. The two limits that we set as the upper control limit and the lower control limit, along with the average in our control chart, helps us to separate common causes from special causes. The common cause of variation is the range between the upper and the lower control limit, whereas the special cause, as the name suggests, is the range outside the bounds of the upper and the lower limits. Some of the uses of the statistical control charts are as follows. Process control allows us to find and correct problems as they occur when controlling ongoing processes. Outcome prediction can use control charts to allow us to predict the expected range of outcomes from the process. Determining stability, as the name suggests, we can use it to determine whether the process is stable, and to analyze patterns of process variation from the two causes that we discussed about, the common and the special causes. And quality improvement is when we're determining whether the quality improvement should be focused on preventing the problem or when we need to make big changes to our system. Then we can use control charts. You would wonder, what are the techniques? How is this technique already implemented in the engineering field? Engineers use this technique to ensure that every one of their manufactured product is following according to set standards, such as we see in food quality or in any other field that specializes in producing mass supplies of stock to the public. I mean, that is that reason why we don't have defective products as much. But that should be the end of it. Thank you.